Hi all, in this second video regarding the stack, we need to implement the linked list implementation of stack operation. We already discussed stack has some operation like pop, push and top operation. So that kind of top node because we are getting the data, top data. So we need to implement with the help of a linked list. It is challenging, right? So in this program, we will discuss about this one. So here you can see that first of all, we are implementing stack implement s equal to stack implementing and s dot push. We need to push the item to the stack first. So that is the push operation. So push and pop operation. So before that, we need to check what are the operations are we need to write. First one is you already know class node. That is the declaration of creating one node for the linked list. That means self, this one, self dot data, we are assigning to the value and the self dot next equal to none for the creation of each node, this one. And this class, the stack implementation class we have, first we define the head. Okay, there is no item. If it is, we need to define the head equal to none. And the size, so that time you already know there is no item in that particular linked list. Then the self dot size equal to 0. We can assign. Then the first one, push operation. Push operation means we are getting a data and we insert into the linked list. So first X is the item, right? So first we need to create this node of X. That means first temp is creating. So I will tell you. Hmm. So in the step, we are creating a node here like this 10. For example, 10. So that is the step here. You can see here node. This step node of X means node of 10. So first I am passing to 10. So we are assigning to temp equal to. This is the variable temp. Temp equal to we are creating a node and this is pointing to none. This is the none. So this is the first variable we are creating. Then what we do, the temp dot next equal to self dot head. First next point is we already have a head. We need to create a link here. This one equal to self dot head. So this is the one of self. So self dot head and then we assign the self dot head equal to temp equal to self dot head. We need to move the pointer to head. So this is the head pointer. We are moving the pointer to self dot head equal to temp. We are assigning it here. And size also we can implementing. Self dot size equal to size plus 1. That is the push operation. We are inserting into one item. That means the size also incrementing. So the size incrementing, we can increment. Okay. Size increment and a temp equal to, we already are creating one temporary node. And the next one is you can see here, find the size. Find the size of a linked list. We can use the size of, we are passing the self dot size, we can return. And peak. Peak means self dot head equal to none, then we return this one. Otherwise, we return this data. For example, we need to top item, right? We need the top item. Then what we do, we are using the peak function. That means top function is the peak function. If it is equal to head, then we can definitely return, right? 0 or minus 1. Normally we are return to minus 1, infinity. So return marks dot infinity, we are return. Otherwise, we can return head data, the top head data, self dot head equal head dot data we can return. That is the top item. And pop. Pop means we need to removing the item from the top. First condition is if there is no item, what we do, we can definitely return mark dot infinity, we can return. Otherwise, if it is contain data, we need to rest one temporary variable self dot head dot data and self dot head equal to self dot head dot next and the size minus 1. We need this data, we need to this data, right? This equal to we are assigning that data. For example, if I removing this one, I am assigning to res equal to head dot this one head dot data self dot head dot data we are checking, and then what we want the next element only from the next we want to next one, because if I remove this one, if I remove this one, only this one, right? I need to one. So that is the condition writing here. We are assigning self dot head equal to self dot head dot next. That means the pointer is moving to this pointer is moving to this where. So that is the reason here liking that self dot head equal to self dot head dot next, and decrementing the size. For example, you can see here we are inserting the item here. Then pop s dot pop print means top item we need to print. Peak means what are the after the pop, the 20 is the top item, right? So we will get the top item from here. Size already know the length. We are already defining a variable also here, self dot size equal to 0 when it is incrementing if the item is push, and if it is decrementing the item will be pop. So this is all about the linked list implementation of stack, and it mainly depend upon the time complexity, right? The time complexity is bigger of n. Time complexity is bigger of n. Time complexity is bigger of n, and the auxiliary time complexity is bigger of n, and the auxiliary space complexity is bigger of n. That means it will require a space, right? So these are the time complexity and space complexity. If you have any doubt, let's comment below. We can discuss in the next videos. Bye.